All right, this lesson is on similarity and what it means for figures to be similar. So before we do that, we should talk about the difference between congruency and similarity. If two things are congruent, it means that they are the same size and the same shape. And the key piece right here is that all sides and all angles are congruent, are the same, are equal. So all sides and all angles are equal. All right. Now for similarity, this means that all the sides are proportional. All right. P-R-O-P, proportional. But here's the thing that's really important to know is that the angles are also equal. Okay, so that's the difference. The sides are not equal, but the angles are equal. If they're congruent, it means the sides and the angles are both equal. Now, if you remember, we talked about similarity a little bit, and there's only one type of transformation that will result in a similar but not congruent figure. Think for a second, see if you can figure out for yourself what type of transformation does that. If you got dilation, you are absolutely correct. So I'm just going to make up a random figure right here. Let's do a random four-sided figure. So this is my four-sided figure right here. And I'm going to do a dilation of this figure right here. So in order to do a dilation, I'm just going to go ahead and take this right here. And I'm going to make it smaller just so we can kind of see what will happen. So I'm going to transform it, dilate it, and I'll make it half as big. And this is what my new figure will look like. All right. I'm just going to drag this over so it's separate. Now I want to notice the relationship between the sides of each of these figures. They are obviously not congruent. This side is not congruent to this side, but I can measure it and see if there is a relationship between how big each side is. So this side, it tells me is 5.87. This side right here tells me is 2.93. Now the relationship between this is that this is almost double this. It's about double. So let's look at this right here. If I were to measure this side right here, it's 8.16, which means that this is going to be about half as big because it's actually it is exactly half as big. So I'm going to measure it, and this right here is half as big as this piece right here. So that means that the scale factor from here to here is 1/2, just like we do with dilations. But here's the thing that I really want you guys to notice. I'm going to show you what all the angles are in each one of these figures, and you're going to notice what the relationship is between the angles. So if you take a look at the diagram here, this size, again, this side right here is twice as big as this, but if you look at all your angles, they're exactly the same. So these are both 119, these angles up here are both 94, these angles down here are both 67, and these angles right here are both 80. So if you look right here, I'm going to drag this, I'm going to change it. Now if you notice, the angle measurements are changing, but they're still exactly the same. They're changing with respect to each other, but this angle is still the same size as this angle right here. So here's a way to show you that in fact the angles will always stay the same. Also, I want you to notice that even though the sides change length right here, this side is still twice as big as this side is right here. So I can change the length. I'll make it like 10. So you can kind of see it. So notice this is 10 and this is exactly 5. This is 7.8, this is 3.9, which is half as big as 7.8. So what are the requirements for shapes to be similar? The two requirements are that the sides have to be proportional and the angles have to be equal or congruent. So the angles are congruent. All right, so let's go ahead and take a look at question number 3, and we will answer all the questions. So question number 3 says triangle ABC is this weird symbol to DEF. This symbol right here means that they are similar, just so that you know. So the symbol for similar is just a squiggly line right here. So this symbol right here just means that they are similar. Answer the following questions. Question A, draw a picture of the two triangles. So what I'm going to do is I'm going to draw triangle ABC versus triangle DEF. Now I don't know which one is bigger. I just know that one is the two triangles have proportional sides and congruent angles, and one is bigger than the other, but I don't know which one is which. But it says, do you see how this says A, B, C? That means that this A has to go with this D, since this is D, E, F. The A came first, the D came first, so I'm going to label this angle right here A, and this angle right here D, because those go together. The part B for triangle ABC, I'm going to label up here. It doesn't matter where you put the A, B, or the C, but what does matter is that the corresponding side angles go with the right angles over here. So this is B, which means that up here, I'm going to put an E, and then since C came last in the first triangle, it will go with F because F came last in the second triangle. So these are my two similar triangles right here. Now let's go ahead and answer questions B through G. So question B says, which angle corresponds to angle A? So if you look at it right here, this angle A is the same thing as angle D, so my answer to this is angle D. Please go ahead and see if you can answer questions C and D, and then when you're done, compare your answers with mine. Okay, which angle corresponds to angle B? Angle E, because they're in the same position in the triangle name as well as the actual triangles. And then which angle corresponds to angle C? We'll say angle F. Okay, which side corresponds to side AB? So if I look right here, side AB is this side right here, which means that the side that corresponds to it is side DE. So my answer to this is going to be DE. Go ahead and try question F and G and compare your answer with mine. Okay, in question F, it says which side corresponds to BC. So here is BC, this side is BC, which is the same thing as EF. So I'm going to say that my answer to this is EF. And then what side corresponds to AC? This right here is AC, so I'm going to say that the side that corresponds to it is DF. Okay? All right, so let's go ahead and look at question H. I'm going to label the information that's given to me. So the first piece of information I know is AB is 5. So in my diagram, I'm going to label this as 5. I also know that BC is 8, so I'm going to label that as 8. And then I know that AC is 12, so I'm going to label this down here as 12. I know that the measure of angle A is 31 degrees. And I also know on this side of the chart right here that EF equals 5. So I'm going to label this side right here as a 5. And that angle F is 73 degrees. So then I have to fill in the missing pieces. So what I'm going to do right now is really quickly, let's just look back here. I know that the sides are proportional and that the angles are congruent. So I'm going to focus right now on number 1, the sides being proportional. So if the sides are proportional, then I do exactly what it says. I'm going to use a proportion to figure out what the sides are. So right here, I know that this is 8 and this is 5 and they correspond with each other. So what I'm going to do is I'm going to create a proportion and it's going to say 8 over 5 is equal to, over here, right now I'm going to figure out what DE is. So that's equal to 5, because since I put the 8 first, I'm going to put this 5 second. So it's equal to 5 over this angle right here, which I don't, or sorry, this side right here, which I don't know, so I'm going to call it X. Now let's see if you remember how to solve a proportion. You just cross multiply. So 5 times 5 is 25. 8 times x, cross multiply those guys together too, you get 8x. Divide both sides by 8. You can use a calculator if you must. It's not a big deal if you don't, or if you, I'd rather you don't, but if you must, you can. And that means that x equals 3.125. Okay, so that means that right here, for side DE, because that's what I just figured out right here, I can fill in that it's 3.125. So I'm going to label this right here as 3.125. All right. All right, so this is now known information. I know that this side is 3.125, so I will go ahead and label it inside of there. Now, I'm going to do a similar process to figure out what side DF is right here. So I'm going to call this side right here X or Y or whatever variable you want to call it. Actually, let's call this variable Y, so it's different. And I'm going to use a similar proportion. I still know that it's 8 over 5. Okay, so I'm going to write down 8 over 5. But this time, the other side that corresponds to this y is 12. Since I put 8 first here, I'm going to put 12 first here, so I will get 12 over y, cross multiply again. 5 times 12 is 60. 8 times y is 8y. Then I would divide by 8 to solve for y, and that means that y equals 7.5. So that means that side DF right here is 7.5. So I'm going to call this 7.5 right here, and I'm going to label it in here because I know how big it is. Now, we've figured out all the missing sides. The next piece that we have to look at is the fact that the angles are congruent. This is where things get very easy. So if I look right here, I know that angle A is 31 degrees, so that means that angle D, since it corresponds to it, also has to be 31 degrees. So that one was an easy one. I can say that this is 31 degrees. Okay, because again, the angles in similar figures are always equal. And then if angle E, I don't know B or E yet, so I can't really figure out what either one of those is yet. So I'm going to leave that blank for right now. I do know what angle F is, though. I know that angle F is 73, and I know that angle F corresponds to angle C. So right here, I'm going to say that this is 73 degrees. Okay, and then lastly, oh, I gotta fill this in right here. 73 degrees. And then lastly, all I have to do is figure out what angle B is. I know that the angles in a triangle add up to 180, so I'm gonna call this here Z. And I'm going to say X, or excuse me, 31 plus 73, my second angle, plus Z, which is my third angle, equals 180. And then all I have to do is just solve for Z, so I can combine my like terms right here. This ends up being 104 degrees plus Z equals 180. All I need to do now is subtract the 104 from both sides. And then I end up getting Z equals, sorry, there's a little bit of a lag, 76 degrees. Okay, so if angle Z right here, which is really technically angle B, if this is 76 degrees, that means that angle E also has to be the same thing, so angle E is also 76 degrees. Okay, and then the last thing that I need to do is find out what the scale factor is. To find out the scale factor, I just take one side and divide it by the other side, right in my calculator. So I'm going to divide 8 by 5. And that gives me my scale factor, which means, so if I go ahead and I do my division, I will end up getting 8 divided by 5, which is 1.6. So that means that my scale factor right here is 1.6. Okay? But I can also take any pair of sides and divide them and see what I get. So if I take this side of 5 divided by 3.125, I get 1.6. And then if I take the 12 and divide it by 7.5, I also get 1.6. So that means that my scale factor is consistently going to be, sorry about that, 1.6. So this right here, my answer right here is 1.6. Question number 4, which transformation will result in a figure that is similar but not congruent to the original figure? Explain your reasoning. I would like for you to answer that, please, and we will discuss it next time I see you in class.